sorry if you stay in the meeting, but it's really important that your sound and
My
your
sound is off.
microphone
My
is
sound is off.
blocked.
Yeah.
And you can use that
Okay.
microphone to speak in the.
Okay.
Cool. Can we leave?
Sorry?
Can we leave?
Well, you shouldn't end the broadcast, but you can, of course, toggle video.
Yeah, that's what we did earlier, isn't it?
And you want
Just
to
minimize the
toggle the
video.
mic, right?
Okay.
I think that's what we get now.
I think that
I'm not
camera is
sure
good
if this is audible.
Yeah, I
to
think so
anybody.
too. Thank you.
So somebody needs to check.
Speaker off. We don't need the speaker here or the video. That's all.
So if you speak in this vein,
Yeah.
then
So that's
people who
on.
are online,
Yeah.
you need to check whether somebody who is online can hear you.
Okay.
Because people can hear us here now, right? Yeah.
He responded.
People online, can you hear us?
Yeah, he heard you.
I'm not sure.
Test him. Ask him to talk. Type. So I thought, can you? Okay.
Perfect.
Yeah.
All right. Then you go.
Okay. Ask him to speak. Just to test.
Testing. 1, 2, 3.
Can you speak just to test your sound?
Testing. 1, 2, 3. 1,
Can't
2,
hear him.
3. No.
It's not muted.
We can't hear you.
All permissions are there. It seems
Very muffled.
everything seems to be fine on my end.
It just sounds like it's super soft.
Yeah.
Can you hear me?
I wanted to get something from me. But then suddenly it came away.
Hello? Can you hear me?
Right? He's supposed to
they
be
would-
silent.
they would only give him financial.
Do I need to speak up?
Yeah, but then he's not traveling. The reason
Yeah, change anything. We need to.
Yeah,
but
but
he couldn't make it anyway. No visa or what issue?
I don't know. That's what I want to say. Maybe it's
In your sound setting, audio setting, we have to select again the Scarlett. Remember we did that earlier?
Yeah, so. Do you remember where?
But I don't know. Do you have sound settings in the app itself? Oh yes, there. Oh no, you're mute. You're muted.
but they can hear us.
Yeah, but you have to unmute you. And I think your sound is popping out of your computer. Or maybe your microphone is open on the application.
No, my microphone is off.
Okay, but sir, no, this microphone is not. You have to turn it on.
I am trying.
Can you hear me now?
Oh, we don't. And okay, if we click on the horn that's there. Right.
Hello?
Sorry.
Can you hear me? Still no?
Sound settings. So we have speakers. Speakers should be good.
You and Jean that you
And crap, what was the?
This is the file.
You and Jean.
Okay, so this is supposed to be good. Now for some reasons the application is refusing to take. If you turn off the camera just to test. Okay, and now are we able to open up the microphone? Yeah, I can hear you. You could. Okay, we can turn on the camera, I guess, for a reason. The microphone is red, but it's still working.
You probably need to do that.
What do I need to do?
Turn around. Oh, that's you.
Yeah.
Sorry.
Just type to him.
I don't need to be there double.
Double mic.
He does say that his microphone seems to work in speaker.
This one that's on projecting.
But my mic is fully off, so it should not pick that up.
Access to this computer.
Yeah, go.
I was hearing you.
It was really off.
Now no more.
No, it is off.
Everything we did differently was disconnected, but maybe.
Cool. Why do we need to?
I don't have that port.
Oh,
I have
think
a really
so.
old laptop.
Oh, there. So that I can give them.
Why not toggle this one on?
But it doesn't take the camera neither.
You mean?
Because I see that the input is taking the I thought it was written built-in microphone. Usually it takes the microphone built-in.
Ask people if
but
they want
now
to
I
move
think
forward or closer together so we can have
microphone
more
is going
open
there,
forward
but I think
discussion. Or do you think that's
this
awkward?
might
Yeah, some
not
people
be
don't
going
like
there.
Yeah, it's maybe
And I was wondering if the camera was correctly plugged on the computer.
I don't like it that
Showing that
everyone is
computer,
facing
camera,
in this
right?
direction
Yes,
because
yes,
that
yes.
makes it hard to
So
have
the,
informal
sorry, the
discussion.
box that was open.
Like this
It
is
was
just
when you take the
feels,
microphone,
yeah.
it's written that
Now
it
it
takes
just,
internal microphone and internal webcam.
Aye.
But it looks
yeah,
like it's
you're
not the
going to ask
case.
questions and people are going
So-
to answer. And I think what we
Let me
want
show
from
you if
the
you click on the
table talks
microphone
that people
again.
talk amongst
Yeah.
each other.
But we cannot.
What's the box?
We cannot
using?
force them. No, I know.
So what
Maybe.
we can do is like just
Yeah, you
ask
can go here.
them,
But I think we should just be really.
open-ended question to them.
I think we should just start off stating specifically what the format of this session is.
But he can
Just
hear
him.
us.
Yeah, hey,
Yeah,
we're
he
not
said
going
we
to
can
present
hear,
anything.
but
It's just
I
meant
think
as
we
an,
can hear him
um,
and he's muted because I
informal
hear
sharing.
us in his computer. When my volume when I open the
Yeah, I
volume,
agree.
I hear
Yeah,
us
yeah,
in Slapback. So I guess there's a computer somewhere that's working. Maybe he's not aware of the mute button. Could it be? I go back.
He can't
I
use
can
mute.
double check if he.
Because now the only issue is you can't hear Santa, right? Otherwise, everything goes.
in broadcast.
Hmm?
In broadcast.
Can you ask him to talk again?
I'm definitely muted.
Who muted him? Can't he unmute himself?
Testing. 1, 2,
Yeah.
3,
Hear him.
1.
We
Yeah,
still have some echo.
We do have echo.
we hear you, but with some echo.
It's still super soft.
Yeah, but he can reach.
Built-in microphone open. I don't know if
Somebody's
it's this
mic.
computer, but if I shut all microphone, I hear you feeding.
Yeah.
I don't know where it's coming from.
Can you just off all the mics?
Well,
If
we
I can
turned
what?
that one off.
Off these mics?
Like, can we shut this computer, or
Okay.
we really need
Do we
this
need this?
computer?
Well, we're broadcasting from this one.
How about
Broadcasting
that?
for this.
We can
Off this one.
switch to that one.
Can I? Sorry.
Yeah, you can do something.
This is the one causing
Yes,
the
it's
echo.
this one. Yes. Can we last thing? We right click on the horn bottom right. I guess the microphone.
We turned it down, right?
I guess if we go in the OS,
No more. No
No
more.
more. I have to turn it off.
we're good.
Apparently, it was.
Better?
That is weird though because
something's
it
coming,
was
and
off.
this is up. This
Can you
is
switch
up.
it off? We don't need it.
It is off. I just can't stop because I'm the one broadcasting.
No, you're fine. This is not the issue. This one is.
Cool. What did you press? This one? Mute it? Okay.
Yeah, but we already did sometimes. It's just magic. It's just magic that it seems to work now.
Okay, just start. It's not a big issue.
Either you're speaking or not. We're gonna be able to meet.
Yeah.
Just start.
Right. So you can go ahead.
You don't.
Nabila and Jean. Come. I'll just be here to give moral support. Maybe where's the remote control? Oh, you
Yeah,
have
here.
it? Okay. I just want to see how it works.
Hi, good afternoon, everyone. Okay, today is our table talk session with the same, thank you, with the same topic from our previous panel discussion, And this session should be very casual, without any formal question. We just having discussion, changing our thought, and also maybe share about your experience from your country, from your institution. So let's begin.
Do they want to start?
We
off?
want to
Oh,
start
Sata.
with Sata first.
Okay, we start with Sata. Here.
Yes.
Okay, I think he want to do some presentation. So let's start. He want to share
Hi.
his slides or
Yeah, can you hear me?
yes.
Okay, perfect. Because I think there is quite a bit of echo on my end, but I think that's fine. I'll just mute. Yeah, as long as you guys can hear, I've just muted my speakers, so that should be fine.
Okay.
I'm gonna try and share my screen. Give me one sec. Are you guys able to see my screen? Okay, perfect. I think I saw someone nodding. So yeah, okay, I'll just go ahead.
One moment.
Yeah,
Gary,
hi
try
everyone.
to
Thank you
get
so
your
much for the
sound
invitation
louder.
to the organizers. So my name is Sarthak. I'm a software architect at UPenn and a technical lead at ML Commons. My prior work has focused on providing computational solutions to problems in medicine. And today I would like to talk to you about a software ecosystem that can enable you towards designing and deploying
Sata,
clinically relevant AI.
can you
So
increase?
let's start with the motivation of why we actually worked on this. As we all know, training robust AI models requires large amounts of data, and specifically data from multiple institutions, so that different patient demographic profiles can be
Hi,
adequately learned by a
can you
model.
maybe turn up
The
the
current
volume on your
paradigm
end?
of forming such
Because
multi-institutional
we can hear
collaborations
you, but it's
based
very
on data
soft.
sharing, where multiple sites decide to share the data to a
Yeah, you should
centralized
use
location.
this.
These can be different data repositories by trusted agencies or in the form of computational challengers. These data sets can then be used to train models for specific tasks. We know that this works, but it simply cannot scale internationally due to multiple concerns, and one of the main ones of them being the regulatory and the data ownership concerns. So, back in 2018, our group was one of the first to publish the use of federated learning in healthcare using brain tumor segmentation data. And since then, we have actually followed up with a study using more than 70 sites across all around the world. The basic concept of federated learning, I'll just give you like a brief overview, is that the model definition is shared between the different data owners, and then the data owners train the model, and then share it back to an aggregator. And the whole idea is that this allows us to overcome a lot of the regulatory hurdles and thus enabling the unlocking of data silos. So after we published this work, we actually realized that the code can be put together for significantly broader use case instead of just neuro-oncology. Um, with that in mind, we started discussing about multiple technical considerations because the code needed to be deployed to multiple sites, and it can be done by following the specific RRR of software practices, as we like to say, robustness, which is the ability of a system to function correctly in the presence of invalid inputs. Reproducibility. So this is the ability of a system to replicate a computational experiment, and reusability. So this allows existing software and tools to be built, to be used to build new applications. And an easy way to achieve RRR supremacy is by using version control. So basically, anything that is not cloud storage, like anything related to Git, primarily that's version control. So unit tests. So this ensures that we test individual pieces of code, continuous integration to make sure everything is up to date and synced, and continuous deployment. So we test the runtime of the code on target platforms. And finally, object orientation, which allows us to write modular chunks of code. Um, And yeah, I would like to mention commercially friendly licensing, because we really cannot advance science without having the commercial backing of multiple companies, and we need to ensure that our code does follow a commercial friendly license. And I'm happy to talk about that afterwards offline. So with this all of this in mind, I would like to mention the comprehensive federated ecosystem, or COFE, or it is also known as the Comprehensive Federated Ecosystem for Everyone, or COFEFE, because not all typos have to be meaningless. So, Coffee is basically a holistic ecosystem of open source, commercially friendly software tools that enables multiple computational studies in healthcare, and with a unique focus on federated learning and federated evaluation. So, I will just go through this really quickly. Please feel free to ask me questions. So, we start with the FETS tool. So, this is essentially a singular platform that allows end-to-end processing of neuroimaging data, including harmonized pre-processing, a wide library of pre-trained models to enable multiple solutions, um, manual annotation tools, and then finally model training. Then we have the generally nuanced deep learning framework, or Gandalf. And what like the whole idea of Gandalf is that we there are multiple steps in a research project pipeline, and as a researcher we have to think about the different components during the entire life cycle. So we have conceptualization and design of the experiment, the actual development, and the evaluation. So the conceptualization involves the identifying the use case, checking for the available data, potential impact, experimental design, and all of this is the thought process. And then the development is focused on designing of the data IO, curation, pre-processing, the actual DL algorithm, and then the evaluation is cross-validation of the model to ensure that we are not overfitting, and the appropriate metrics. And all of this is basically the reproducibility and potential clinical translation. And again, as I was mentioning, as a researcher, we have to focus on the specific component that makes most sense to you. And with the development of Gandalf, we wanted to focus on the development and evaluation portion, and not really the conceptualization and design, which is more research focused. And yeah, so what this basically is the algorithmic core of all of our federated learning studies that we have done, and it includes I/O and anonymization, specifically for radiology histology. But like I'm giving imaging as an example, but this can be extended to pretty much any kind of healthcare data. There is harmonization, intensity resolution. We have robust data augmentation, training, the network topologies, obviously, that supports both segmentation, classification. Then we have a very robust and customizable training pipeline that includes cross validation and a wide ability of customization. And then finally, we have post processing that includes multiple image processing tasks and specialized inference for both radiology and histology images. And the best part is all of this is encompassed in a zero code design principle. So what this means is that you can define, as showing this example, you can define a 2D unit with residual connections with a softmax final layer to do binary segmentation just by using a few lines of text, not even code. Um, and we have open community calls, of course, and please feel free to join us. We obviously would like to chat more. Now, moving on to some of the free benefits of Gandalf. So you get interpretability through webcam. So this allows you to interpret what the AI model is actually seeing when it's making some specific predictions. And then you have support for secure containerization, MLQ, Singularity, Dockers, and it allows automatic model deployment using a single command tools for pretty much any kind of target operating system and platform you have out there. Um, Now, with Gandalf, we have had multiple peer-reviewed studies. These are just peer-reviewed, by the way, not archived, and this is which is really, really amazing to see. And we hope that Gandalf can facilitate even more studies, in the future. Now, moving on to OpenFL. So the Open Federated Learning Library forms the federated learning backbone of the FED study, and in addition to being completely modular, it supports pretty much every deep learning framework out there, and it has unparalleled security considerations, of course, which was paramount when we were because we were deploying in clinical sites. And this allows users to scale from simulated to large real-world federations very quickly. And OpenFL also allows us to do model watermarking. So basically, the contribution of individual sites with regards to the model is clearly noted and clearly denoted. And OpenFL has a robust and very strong tie-up with Gandalf, as you can probably imagine, because a lot of the same people have been involved in the development, and we have community calls for OpenFL as well. Now, let's move on to a benchmarking platform that actually was that went online this Monday, MedPerf. And this enables secure and federated access to data. So basically, we start with a benchmark committee that that is made up of experts from both academia and industry that define an experiment that needs to be run. The data owners then see proposed benchmark and record the availability of any relevant data. And the model owners, working closely with the benchmarking committee, can define and register one or more models that they want to evaluate using MedPerf. And once this is done, MedPerf can be used to basically do benchmark evaluation and execution on the registered dataset. And this can then be published or used in terms of results, however, the benchmark committee actually deems appropriate. So we used all of this tool in the first federated learning competition that followed a clinical trial design. And what we mean by clinical trial design is that so usually computational challenges focus on the feasibility and capability of different algorithms, but we have instead focused on the effectiveness. And so by testing trained models from participants across a a wide clinical use case, we were able to quantify how effective different models were. And this is, as you can imagine, this forms the basis to test durability and model drift across time as well. And then moving to OpenVINO. So as all of us have working in AI know that training AI models requires expensive hardware. We typically use workstations that are about 10 grand, and we train really nice models. But clinical reading rooms have don't really have that kind of hardware, and there is this big chasm or divide that needs to be bridged. So Coffee, what it does is it uses OpenVINO to perform post-training optimization to make the model smaller without sacrificing any utility or accuracy. And this has resulted in higher throughput, obviously, but more importantly, it allows a model trained on a $9,000 workstation to run on a $700 laptop. And this, I think, is a game-changing contribution overall and allows telemedicine to move forward. And we certainly believe that open source is the way that science is going to move and progress forward. And we have created Coffee with the ideology embedded into the very ethos of all of these different products. And we want you to use them. So, to make the learning curve as short as possible, we have a vast array of online tutorials and documentation, obviously, but we will also be doing multiple hands-on sessions at different conferences, such as the upcoming one at MECAI and at RSNA. Please check this link for more information. And with that, I would like to give my thank to the organizers for this opportunity and continue with the discussion. Thank you.
Okay. Thank you, Santa, for your presentation. So I believe, Jin, you have any words to add on before you're leaving?
Um, Thank you for inviting me here because I have another session, so I need to leave earlier, but I will leave my comments here. Thank you, Doctor, for your wonderful presentation about federated learning. And from my experience in Taiwan, I work with Taiwan Biobank and some brain image cohort. Yeah. From what we are doing with those brain images was similar, like developing the brain tumor segmentation model for the hospitals, especially for those clinical centers have hierarchical structures, like in the medical center or domestic hospital or the clinics in the remote area. And for what we have been doing is using the federated learning as well, but the horizontal federated learning. And what we encounter is, because I'm from the statistical background, so we are developing some methods for federated learning, especially to deal with the Byzantine problem, because when several small models training locally, we need to keep the main model robust enough to do the job. Yeah, so just in case if any small models that have some bad intentions or attack to the general model, we try to develop the method to conquer that problem, to keep the major segmentation model robust enough. So that's from my experience. And I'm sorry I need to leave earlier. Yeah, but the open science will always be very welcome to you guys to ask any questions, and I'm sure my colleagues will have lots of suggestions as well. Yeah, thank you.
Thank you, Jane. So if you have any question from the SATA presentation or any doubt, you might want to
Or
share with
comments.
comment.
Actually, this session is like a sharing. That's Sata, thank you. And we're going to have this informal discussion around this topic.
Okay, for SATA as our online guest, thank you for your presentation. So here we're gonna have informal session among the face-to-face
attendees.
participants. Okay, thank you, SATA.
Oh, yeah. Yeah, we can end.